metal cutting. We're going to start with tools that are more specific to metal rather than composites. As a general theme, the tools for metal are stubbier than the others. You'll see a lot of tools that have very low stick out, very high rigidity. Like this tool, they'll often have large radiuses for supposedly square end mills. Even when you get down to something like this, this looks like a square end mill that you'd have on a plastic or a composite, but actually there's a 10,000ths radius on there, maybe a 7,000ths radius, but really no smaller. That's just a result of the way the heat builds up on those sharp tips. They basically don't last very long if you have exactly square tips on the square end mills. When you get into really high quality metalwork, you always have a small radius. You always have some kind of radius on supposedly square end mill. This is a really nice steel mill. All of them basically have these radiuses, including the shell mills. So back to just removing a lot of metal. For interrupted cuts, a negative rake angle. This would be something that you would use on Monel or some kind of difficult to machine metals. The nice thing about these negative rake configurations on the insert, they basically allow it to work on geometry that's much more interrupted than a positive rake. This configuration basically takes less horsepower. This allows you to work on a wider variety of shapes. So if there's a giant gap in the middle of your cut or already holes drilled out, when you use a positive rake, there might be some more cutting artifacts by that border. Whereas with a negative rake, although it takes more power on the part of the spindle, you get a more even cut. You basically have to experiment. It's very nonlinear, different results depending on what region you're operating in.